Hi, this is lesson 5.5, and in this lesson we are going to be solving equations by finding the roots. All right, I skipped a page here too. So, first of all, we want to talk about some equations that we have solved and found the roots for. So first of all, these are both quadratics, and we can factor this first one. So let me go ahead and get a pen on. And that one will factor. Now, if we couldn't factor, remember, we would use the quadratic formula. Now, the factors of 12 are 4 and 3. And if we have a minus 4 and a plus 3, that would give us this negative 1 right here. And then once it's factored, so these are the factors, we're going to set each of the factors equal to 0. So x equals 4. And x would equal a negative 3. Now, what x is equal to, those are called the roots. They're also referred to as the solutions. Sometimes they would be called the zeros, or they can be called the x-intercepts. Okay, so any of those names mean these answers right here. This next one, let's go ahead and factor that. We'll see if we can. So 2x times x, and then we have to do the factors of 3. So either 3 and 1 or 1 and 3. So I think it's going to be like this, because that's 6x and 1x, and 1 minus 6 would be a negative 5. So that would work. So now to find your roots, we set those factors equal to 0 and solve for x. So x equals negative 1/2. And x equals 3. So those are the roots of the second one. Okay. Now let's talk about how we found the roots of a polynomial equation that's to the third degree. Okay, so the largest exponent is 3, so it's a third degree equation. So if we know that x plus 6 is a factor, we know that that will divide evenly, and what's left over is another factor. And so on our assignment on Friday, we use synthetic division instead of doing long division. You can do long division, but we can also do synthetic. So if x plus 6 is a factor, we know that x equals negative 6. So we're going to do synthetic division using negative 6. So we have 1, 12, 44, and 48. All right, so the first step with synthetic is bring down, and then you multiply. Then you add. Now we multiply, and then we add. And then you multiply, and then you add. Okay? So there's no remainder, and like I said, there shouldn't be because that is a factor. So now, when we divide, then what's left is we have 1x squared. If this is x to the third, this is x squared, plus 6x plus 8. So then this becomes a new factor. The first factor was x plus 6, and then this is another factor. Now that can be factored again. It's a quadratic, so at that point you factor. And then 4 times 2 is 8, and 4 plus 2 is 6. So these are the factors. And then to solve, we would set each of those equal to 0. So your roots would be x equals a negative 6, negative 4, and a negative 2. Now, that's how you do a problem like that is to the third degree. And we were able to do that because we knew that x plus 6 was a factor, so we could divide that in and just work from there. But my question for you is, how do we do it if you wouldn't have known that x plus 6 is a factor? So fortunately today we're going to talk about a theorem called the rational zero theorem, which says that all of the possible factors can be written by looking at P over Q. And what the P stands for is the factors of the constant term, so the last term of the polynomial that doesn't have an x by it, over the factors of the leading coefficients. So let me show you how that works. So that's the rational zero theorem. So whenever I see that, I think, okay, it's P over Q. So for example, we worked out this problem. But let's say you didn't know how to factor it or whatever. You wanted to look at what are all of the possible factors. So what you would do is you would list the factors of the constant term. So in this case, it's a negative 12. Well, the factors of 12 are 1, 2, 3, 4, 6, and 12. But here's the thing. The number actually is a negative 12, so you could either have negative 1 times 12 or positive 1 times negative 12. You could have positive 2 times negative 6 or negative 2 times positive 6. So all of these need to have a little plus or minus sign, and that's kind of the most annoying thing about this whole thing, but you definitely need to write that, okay, because those are all possible factors. Now the coefficient, or the leading coefficient, is 1, so plus or minus 1. Actually, it's just a plus 1. So all of these are getting divided by 1. Well, actually, 1 times 1 and negative 1 times negative 1 is 1. So in this case, your possible factors are 1, 2, 3, 4, 6, and 12. Those are the possible answers. Like 7 times a number doesn't equal 12, so 7's not on that list. It's not even a possible factor. But sure enough, the answer is negative 3, which is here, and a positive 4, which is here. So in this next problem, let's look at what the P over Q would be. So first, in the numerator, you have the factors of the constant, so plus or minus 1, plus or minus 3. In the denominator, you want to write the factors of 2, so plus or minus 1, plus or minus 2. So now, we have to look at, and I know you're not used to this, but what this is saying is you're going to take 1 and 3 and divide by 1, and you're going to take 1 and 3 and divide by 2. So 1 divided by 1 is 1, 3 divided by 1 is 3, and then you're going to have 1 divided by 2, and 3 divided by 2. So these are all of your possible factors. Now, sure enough, negative 1/2 is an answer, and 3 is an answer. Okay, so now let's go ahead and do another problem like that. It says list all possible rational zeros using the rational zero theorem. So when you see rational zero theorem, I want you to think the P over Q, okay? So P is the factors of the constant term. So that would be factors of 16 are 1, 2, 4, 8, and 16. And then the factors of 4. Okay, so we're going to take all of these and divide by 1. And then we're going to take all of these and divide by 2. So it'd be 1 divided by 2 is 1/2. Now, 2 divided by 2, that's 1, and that's already on the list. We don't have to list it again. 4 divided by 2 is 2, and that's 2. 8 divided by 2 is 4, and that's on the list. And 16 divided by 2 is 8, and that's on the list. Now we take all of these numbers and divide by 4. So 1 over 4. All right, now 2 over 4, that's 1/2, which is on the list. 8 over 4 is 2, which is on the list. And 16 over 4 is 4. So these are the possible rational zeros. Or those are the possible roots for that equation. So what we're gonna end up doing is dividing those in until we find one that works. And luckily we've learned how to use synthetic division because that will go a lot faster. All right, so in this next one, we'll take the factors of 10, plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, and the factors of 4. So we're going to take all of these divided by 1. And then take all of these divided by 2. So that would be 1/2. 2 over 2 is 1. And then 5 over 2. And then 10 over 2 is 5. And then we have 1/4. 2/4 is the same as 1/2. 5/4. And then 10/4. Now 10/4, if you reduce that, that's 5/2, and that's already on the list. So those are your possible roots. And when you write those on a test, you have to make sure you write the plus or minus, or you would lose half of your points. Okay, we're going to skip over that next example, and then we're going to actually apply this. So it says list all the possible rational zeros. So we're looking for the roots of the function using the rational zero theorem, and then we're going to find the factors and the roots. So first of all, we're not given any factors, so we're going to use the P over Q. So we're going to have the factors of 16. And then the factors of 3. Okay, so what we have then would be 1/3. Excuse me, let me go back here. So we would have 1 plus or minus 2 plus or minus 4 plus or minus 8 plus or minus 16 plus or minus 1/3 plus or minus 2/3 plus or minus 4/3 plus or minus 8/3 and plus or minus 16/3. All right, so now some of those, we're going to have 3 answers to this, and we'll talk about that in a little bit here. But out of this list, there are 3 answers. So to figure out what they are, we're going to start by just dividing in until we find out what goes in evenly. Because remember, factors will divide evenly in, and there is no remainder. So we'll start with +1. That's the first number on the list. -4. -28, and -16. So we have 3, -1, and that's going to be a remainder. So that's going to have a remainder. You'd add that up. So we know it's not a +1. So now we'll try a -1. And again, there's a remainder. I'm just going to put an X there because we know that that's not one of the solutions. So +1 and -1 do not work. So now we'll try 2. So then we have 6, 2, 4, -24, -48. And that does not work. So we'll try a -2. Okay, so we have 3, and that's a -6, which is a -10. That is 20, which is a -8, and that's a +16, and there we have it. So that would be 3x squared, now this is a cubed, so this is squared, minus 10x minus 8. Now, -2 worked, so I'm going to circle that. That's a root. So the factor was x plus 2, so that was the factor. All right, now, this is also a factor, but this can be factored again, because we're at a quadratic, so we'll factor it. And if we couldn't factor, we'd do the quadratic formula. Let's see, 4, so 4 times 3 is 12. 4 times 2 is 8. So if we have 12, make it a -12 plus 2, that would give us a -10 in the middle. So these are the other factors. I'll write the x plus 2 also. So these are the factors of that. That's factored as far as it can be. And then to find the roots, you're going to set each of those equal to 0. So x would equal a -2. 3x plus 2, set it equal to 0. So 3x is -2, divide by 3. So x is a -2/3. And then x minus 4 equals 0. x equals 4. So these are the solutions or your roots. Now take a look. All of those, negative 2 is here, negative 2/3 is here, and 4 is here. So those were, all your roots were in that list. All right, let's take a look at this one. So again, we're going to first list all the possible rational zeros of the function using the rational zero theorem, P over Q. And then we're going to find the factors and then the roots of the function. So the P is the factors of 8, the constant. And the Q, those are the factors of 1. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. And then we're going to have 1/2. 2 over 2 is 1. 4 over 2 is 2, and 8 over 2 is 4. So these are your possible roots. Now, what we're going to do is start with 1 plus 1 and divide that in. So we would have 2, and then that's a 2, and then 4, and that does not work. You have a negative 12 there, remainder, so it doesn't go in there evenly. So now we'll try minus 1. And there we go. That one worked. Negative 1 then is a root. Okay, so that divided evenly. So if this is 2x to the third, if you were doing long division, this would be 2x squared plus 0x minus 8. So 2x squared minus 8 is what the next factor is. So if this is an x minus 1, that was an x plus 1. Okay, so those are your factors. Whoops, and I have some left over here. Let me just erase. Now, this can be factored if we set these equal to 0. This can be factored again. You can take a 2 out of both terms. So now, if you factor this, you would have x plus 2, x minus 2, and 0 divided by 2 is 0. And then you can, these are the two factors, and you also had the x plus 1 as a factor. You just set those all equal to 0. So x equals negative 1, x equals negative 2, and x equals 2. So those are your solutions, and those numbers are all on that list. All right, real quick, I also want to talk about the fundamental theorem of algebra. It says a p of x is a polynomial of degree n, and the n has to be greater than 1. Then p of x equals 0. So in other words, when you set it equal to 0, usually you would factor it, set it equal to 0, there are exactly n roots, which include the multiple and the complex roots. So in other words, this is degree 4. This is a 4th degree. So that tells you there should be 4 solutions or roots. Okay, this is a 3rd degree. So this will have 3 roots or solutions. Okay, so just keep that in mind. Now that's going to come in helpful when you get to a question like this. It says, what are the zeros of this polynomial? Now, first of all, it's a 4th degree. So there should be 4 solutions or 4 roots. Now here's the thing. If we go back right here, those are, those roots include complex roots, which, remember, that means they have an imaginary part. So when if you were to use a graphing calculator, is what they did here, and this is what it looks like. Well, here are 2 x-intercepts, which are roots. X equals 3, so we know that's an answer. X equals minus 3, that's another answer. Those are real zeros. Now, because it's an x to the fourth degree, there should be 4 answers. So in order to get the other 2 answers that would work, if you plugged it in when you set it equal to 0, the other 2 answers that would work, what we're going to do is use synthetic division. And even though we don't have any factors just right away, we know that if minus 3 and 3 are roots, that factors would be x plus 3 and x minus 3. So to find the other ones, we don't have to do the p over q. We can use a negative 3 and a 3. So let's go ahead and do that. We're going to divide 3 in. So that's a 3, 4, 12, 5, 15, 6, 18. Oh, remainder 0, which we knew it would be because that is a factor. So this was x to the 4th. So this would be x to the 3rd. Now, we're not down to a quadratic, which means we have to do this process again with another number. And we know that negative 3 also works. So when you do this process, what you want to do is take that number and divide in to the new polynomial. So we have a negative 3, negative 3, negative 6. Okay, so now the new polynomial is this. So this was x to the 3rd, so this is x squared, like this. And then lastly, then, to find our last answers, we're going to try to factor that. And if you look at that, the signs have to both be positive. So this cannot be factored, which means we're going to use the quadratic formula. All right, so x equals negative b plus or minus the square root of b squared minus 4 times 2 all over 2. So that would be a negative 8. So, oopsie, 1 minus 8 would be negative 7 over 2. And we can't have a negative, so I'm going to scribble that out and put an I right there. So the answers are negative 3, the roots are negative 3, 3, and minus 1 plus or minus the square root of 7i over 2. So there you have 1, 2, and then 3, 4 answers because you have a plus and a minus. All right, so on the worksheet, I just want to work out number 4 with you. All right, so number 4, first of all, you have to find the possible roots, so you do p over q. The factors of 24 are here, and then the q is 1, so the factors of 1 are just 1. And you can pause this so you can kind of catch up with me. And then we're going to go ahead and start dividing in. Yeah, that does not work. So we'll try negative 1. So some of these, it's going to take a little bit maybe. Oh, there we go. So negative 1 works. Now that's an x to the 4th, which means we're going to be getting 4 answers. So this is, if this was x to the 4th, this is x to the 3rd, x squared, 20x plus 24. Now we have to keep going with this process, but now we're going to use the new polynomial. So plus 1 and minus 1 we tried. Now we're going to go to 2. So we'll use our new numbers. So we have 2, 8, 16, 36, 72, and that's not going to work. That would be a remainder. Now we'll try negative 2, and I'm going to erase right here. Make that a negative. So bring down the 1. We have -2, which is 4. -8, and that gives you 12, and -24, and that's the winner. So there's another factor. Now this was x to the 3rd, so this will be x squared plus 4x plus 12. Now we have a quadratic, so we can solve it. Now, if you look at that one, you're not going to be able to factor it. Okay, so you're going to have to do the quadratic formula on that. So -4, and then b squared is 16 minus 4 times 12, all over 2. So 16 minus 48 is, let's see, 48 minus 16 is a -32. So let's see, 16, or 32 is 16 times 2. So the square root of 16 is a 4. So 4 comes out front. You're still going to have the square root of 2, and the negative becomes an I. Both of these get divided by 2. So the final answer then is a -2 plus or minus 2. These are become 2's. And then root 2i. So there are 2 answers there. -2 plus 2 root 2i, and -2 minus 2 root I, and then -2 and -1. Can you hand me that sheet, Noah? Okay, last thing I want to tell you on this worksheet, just a few hints here. So on number 3 on the worksheet, there's not an x squared term. So put in 0x squared. So when you do your synthetic, the numbers would be 1, 0, -31, and -30. On number 9, you're also missing an x term, so you have to put in 0x. And then for number 5, 6, and 10, when you do your synthetic division, I'm just going to give you a hint that +1, -1, +2, -2 don't work for none of those, 5, 6, and 10. So start at +3 with your synthetic division. That will shorten this up just a bit. Thanks for watching.